Jerome JT62 back here with you once again. In this video, what we're going to look at is tool change and auto tool 0. And your options, or at least the options that work for me, may work for you. As we all know, there's many different ways to go about manufacturing parts, whether it's 3D printing, such as this reducer for this vacuum cleaner hose, or milling out actual parts. And the next video coming up, we're going to talk a little bit more about the dust collection system, but I actually need this router to do some things for me, and that prompted a video of these two components. So if it's something you're interested in, it's coming right up. There's many choices that you have as far as zeroing your tool on your work surface. This is my original 0Z plate. So long as you have the dimension and the thickness of this material, it will set your bit to the top of this. None of the paper thing or trying to figure it out. You can move into a more advanced setup. This is from the Maker Guide. It's called a Triple Edge Finder by Griggs, in which you set this in the corner of your material, bring your bit down as long as it's below this surface, and it'll do an X pattern in here, and it'll find that exact corner, whether it's rounded or not. So I did purchase this a while ago, finally got around to hooking it up. It's not as straightforward as it may seem. I'll link you to Lindsay's website. He does an excellent job explaining the files and how to install this. Although he does use the Xylotech or Xylotex, one of those, their box. It's still pretty much the same, except for he doesn't have end stops and proximity sensors, or these are basically the same things such as I have. So there was another code that he used, or script, to make it work. But in my system, I have everything that's required in order to make this work, including the permanent plate and the removable plate for tool change. You don't need the permanent plate if you're just doing a single basic probe. But if you're going to do a tool change, there's no other way to find the top of your height once you pull that bit out and you've changed those settings. Hence, that's what this is for. It sets the nominal height of the table to your work surface, subtracts those, and you're ready to go. So when you do a tool change, it's going to come back here. It's going to say tool change. It's going to go to a specific position, and we'll get to that. You do your tool change, you hit tool 0, it's going to come back, touch this plate, it's going to come back and start cutting again. The important thing to remember is if you have a permanent fixed plate and your mobile plate, once you do the initial setup, you no longer need this plate again, because your coordinates in your DRO are always going to be on top of this work surface because they're already entered once you do that initial setup. That's the good thing about the triple edge finder. You can also use even a plate like this. If you use Mark Lindsay's method, you don't need to find the exact edge. You can probably eyeball it, but the triple edge finder always finds the exact apex of this edge. So since you no longer have to worry about the tool change, if you had something where the corners were now rounded over, or you were doing something else and this won't fit, no longer fit on this corner, or the only flat surface you had was out here, with this permanent fixed plate, you no longer need this once the initial setup's done on your workpiece. So to get this set up, we all know that Mach 3 likes scripts. You're going to have to find somebody that wrote one, or you're going to have to do it yourself. The good thing about this maker's guide is that it relies on BigTex's blue screen. There is a blue screen on Mach 3's downloads, but unfortunately you're going to have to pay for BigTex's screen set. But the good side is it's only $20, so if you're looking for costs on this, you probably look at about $75 for the maker's guide, or at least that's what it was when I bought it, and another $20 for the screen set. There's others out there you can use, but this one works not out of the box, but it works out of the box. There's no other scripts or anything else that you are going to have to put into your machine. Again, I'm going to link you to Mark Lindsay's website, and he's going to do a much better job of explaining what you need to do to get the blue screen set installed. And what you have to do is basically open up Mach 3 mill. You're going to have to set your machine up. And hopefully you've already got that done. If you don't, this is probably farther along than we need to be. And you need to get that set up. I kind of suggest that you set your machine up. This is for me. This is solely for me. I set my machine up with Mach 3 mill, so in case anything goes wrong, my settings are always there. This is a lot of work to set one of these machines up. So once that's all done, what you're going to do is we'll go ahead and close this out. Is you're going to download and pay for BigTex screen set. You're going to open it up, and what you're going to do is you're going to go to Mach 3 loader this time, and you're going to double click that. Or actually, it's not doing what it's supposed to do here. Let me end that. You're going to want to double click Mach 3 loader, not mill. Want a shortcut to that. And then what you're going to do is you're going to create a profile, rename it whatever you want. This one is JJCNC, and you're going to hit OK. Once you do that, You're going to close that screen out. You're going to come back to Mach 3 loader, and this time I'm going to load JJCNC. I'm going to hit OK. Now I already have Mach 3 or the big blue screen set loaded, but you're going to see the normal screen set. And what you're going to do is go to View. If I can get that in there, you're going to go to Load Screens. And then wherever you saved BigTex's screen set, which you should be on your desktop, that's where I would save it. You're going to load that screen set. Again, Mark Lindsay will go over this way more in depth than I do, but this is the short of it to keep this video short. So we'll go ahead and cancel that, and what's going to happen is this is going to open up. I also suggest that you look at BigTex's channel as far as the settings you need to make in here, because a lot of them are very important. This one here, your park location, your fixed probe location. And then if you go up here to settings, your tool change location. So how do you get those? What you want to do is just go to zero your machine out, park it in the location that's 0, and all you have to do is jog to the locations where you want to do your tool change, where you want to park, and where your fixed plate is. So you do one at a time, then you go back and enter those settings into these screens here. And just make sure that you press enter. So once you find your, come on, focus for me, baby. Once you find your park location, that's where you want it. Enter it here. In my case, it's X0, Y 1.6866. Just make sure that when you click that, you enter that coordinate, that you hit enter. If you don't, it'll revert back to whatever it originally was. And then you don't want any surprises. So for all the settings you put into this screen, make sure you hit enter after each one. Don't just come out of here and go to the next one. Enter a value and then go to settings, or it's not going to see that value. It won't retain that value. We'll put it that way. And you're going to have to do it again. Another big thing you need to do is measure the thickness of this bottom plate. We're right here in this inset. And enter that in your plate offset. And again, hit enter once you get that value in there. We all like to be lazy and use the digital calipers. I would almost recommend that you use mechanical, old school stuff. The digital stuff, the numbers jump around. It's always a couple hundred thousandths off. It's on, it's off, it's on, it's off, until you find a sweet spot to where it's consistent. If If you use the old school mechanical calipers, it's going to be pretty much the same every time. You may have to check it twice, check it 3 times, and enter those settings. So I'll give you a little run through on how I have everything set up. This spindle, and that's the good thing about having an actual spindle, I only need 1 wire, and that is for this mobile touch plate, which is the positive. This whole machine is grounded to the 120 plug, and it's also grounded to this whole machine. Everything's grounded basically through this spindle. Now I have to tell you, when you buy these Chinese spindles, that fourth wire, most likely there's about a 99.99% probability that it's not connected, and you need to pull the 4 screws out here and lift it up and look for the vacant plug. The other 3 are UVW, I believe. They're already connected. Look for that vacant plug, and all I did was put a wire and, you know, just enough length so I could loop it around, and then just feathered it out and pinched it to the top of this. It's pinched in here. There's other methods, you can solder or whatever, but that worked for me, and it grounds this whole machine. So I don't need a clip here because I already have my negative. So when that touches this plate, which incidentally I made removable, if I don't need this for some reason, I can take this off. Just remove it like this, and I take that plate off. So if I was just doing a single bit and I didn't need it, and maybe my clamps or something were in this area, I can just take that off. I don't need to use it. But generally I'll probably leave that fixed. My ground, again, back into the breakout board, comes through here. All I gotta do is clip it to the machine. There's my ground. The whole machine's grounded, so I see it ground no matter what I touch. And then for your movable plate, you have your mobile wire. You just run it back over, plug it in, and get going. I'll give you a little demo, just show you how it works. We'll go from there. So I have my fixed plate reinstalled. Takes about a couple seconds, and basically what you want to do is jog the bit down so it's in here so we can find the corner. I have my positive plugged in, and we'll go ahead and set that up. We'll be right back. Had a little bit of a blooper there, but we'll go ahead and finish this up. I went ahead and zeroed my DRO in the corner, or we did a reference all home, and then brought the center of the bit into the circle so that it's below the surface. And we'll go ahead and do a 0 again. I don't have anything tied down here, so there is a delay in here. And I'm going to go ahead and hit the crosshair right here. I'm going to spin you around real quick, and we'll re-zero this. Should touch off on all 4 corners. So I guess something did slide around, so I'm going to go ahead and zero that Y. I don't know why that's blacking out like that. I may have to contact BigTex about that. But nevertheless, this is zeroed. So if this was a single change, all I'm going to do is page up here. And I'm going to jog over so that I'm above this plate. Doesn't matter where, really. And then I'm going to come back here and the Z down button here, I'm going to hit that. And that'll retract to the setting which I put in. I kind of forgot to mention that, but in settings, this negative number is a number you want to enter on how low you want it to be below the limit switch. That's why you need limit switches. You can't use soft limits. You have to have physical mechanical limits, and I have it set to 3/4 of an inch. So now that that's up, and this would be for single, no tool change. And what we're going to do is we're going to go to 0. I'll go back to program run, it's easier to find. And we're going to hit go to 0Z. If you look at that, you see it's right in the corner. Perfect. Every time. Now if I were going to do a tool change and there was going to be multiple tools involved, it's going to be the same process. You're going to find your corner, except once you're in your corner there, we're already at the corner. What you're going to do is jog this, doesn't matter where again, to any section of that plate. This time we're going to go to initial setup. What it's going to do is touch off this plate. It's going to come back here. It's going to touch this plate. It's going to do its math, figure out where the top of my surface is, and it's going to come back here. Here we go. And these are the DROs that I entered for center of this plate. It's going to touch off. And it's going to come back to the material. So if I hit go to 0, it should be in this corner. So I go to 0 in this corner. Exactly where it was. So when I get to a tool change, spindle will retract. It's going to come back over here to my, let's go back to settings, the settings that I put for tool change location, which is 0.0478. on the X, which is basically 0 almost, and Y 6.563. I'll come back, we'll park back here, I'll do my tool change. Once I do tool change, let's get back into the program run. You're going to go to 0 tool setup. Once you put your tool in, it's going to come back from that location wherever I have it set. It's going to touch this. Going to come back over here, start cutting. In a nutshell, that's how it works. So to close this out, I did put my park, which you can click and it'll park back to where you want it. And these spindles are very heavy. I need to find a gas strut or something to keep this from settling. It likes to pull through. They weigh about probably 18 pounds. So when you power off, they settle down. So important thing to remember is probably remove your bit there, because it's going to come back down to the table eventually. If anybody has any questions about how this is set up, as I said, I will provide links to the websites that you need to view, which will help you in setting this up. My video is kind of a short thing to show you how to get this done. Works very well, very great. So, once again, please like, comment, subscribe. Questions, I'll answer them as best I can, or find an answer for you. Once again, thanks for watching.